Over the course of billions of years, Earth has endured a staggering series of cosmic catastrophes and geological upheavals. It has been relentlessly bombarded by massive asteroids, endured violent collisions with other celestial bodies, and has frozen solid in ice ages so extreme that they nearly wiped life from its surface. And that's not even mentioning the wildly diverse and bizarre creatures that have ruled the land, sea, and sky, some peaceful, some terrifying, and many now long extinct. When we look at the chaotic and violent history of our pale blue planet, it's almost miraculous that Earth has made it this far, let alone become the cradle of intelligent life. Yet here we are, spinning through the cosmos on a world that has survived cataclysms beyond imagination. The scars of its turbulent past are etched into the rocks beneath our feet and written in the DNA of every living creature. From fiery beginnings to glacial standstills, from microscopic microbes to towering dinosaurs, Earth has been a stage for both devastation and miraculous rebirth time and time again. To truly appreciate the depth of our planet's resilience and our place in its grand story, we need to travel far back, beyond the rise of cities, before the age of mammals and dinosaurs, deeper even than the formation of oceans and atmosphere. We must return to a time when Earth wasn't even a planet yet, when all that existed was a swirling cloud of gas and dust floating in the emptiness of space, waiting for gravity and time to work their magic. This is where Earth's story truly begins, not with humanity, not with the continents, but with cosmic chaos, stardust, and the unimaginable conditions that would one day give rise to life as we know it. So buckle up, because this journey through Earth's history is not just a timeline, it's a saga of survival, transformation, and astonishing evolution against all odds. Around 4.5 billion years ago, before our planet even had a name, the vast emptiness of space witnessed the birth of something extraordinary. Out in a remote corner of the Milky Way galaxy, a dense, ancient cloud of interstellar gas and cosmic dust remnants of previous stars long since extinguished began to collapse under its own gravity. Slowly, almost imperceptibly, this immense molecular cloud spun into a flattened disk. As it spun faster and contracted inward, immense pressure and heat built up at its core, triggering a monumental transformation. Hydrogen atoms began fusing into helium, releasing vast amounts of energy. And just like that, a star ignited, the one we now call the Sun. With the Sun blazing at the center, the leftover gas and dust began to organize itself. Tiny particles collided and stuck together, forming larger and larger clumps through a process known as accretion. These clumps were the raw building blocks, the planetary embryos that would eventually become the familiar worlds of our solar system. Out in the colder, more distant regions of this disk, where sunlight was faint, the clumps were mostly composed of ice, frozen gases, and dust. These would grow into the gas giants Jupiter, Saturn, Uranus, and Neptune. Closer to the Sun, however, where heat stripped away most of the volatile elements, only the denser, rocky materials could remain. These gave rise to the terrestrial planets, Mercury, Venus, Mars, and of course, our own Earth. At this early stage, Earth was nothing like the blue marble we see today. It was a molten inferno, a chaotic, turning ball of liquid rock, bombarded incessantly by asteroids and comets that rained down from space like cosmic artillery. These violent impacts delivered not only destruction, but ingredients for the future. With every collision, Earth absorbed more mass, growing larger and gaining gravitational strength. Its surface, constantly reshaped by volcanic eruptions and internal heat, released massive clouds of gas, hydrogen sulfide, methane, carbon dioxide, and steam. These gases rose into the sky and formed Earth's first primitive atmosphere, a suffocating, toxic shroud unlike anything breathable. But the true turning point came in the form of a cataclysmic event, an interplanetary collision of epic proportions. A Mars-sized object, which scientists have named Theia, veered on a collision course with the young Earth. The impact was so powerful it nearly obliterated both bodies. Massive plumes of molten rock and debris were blasted into orbit, forming a glowing ring of material that encircled the shattered Earth. Over time, Gravity pulled this debris together, and piece by piece, our moon was born, an eternal companion forged in violence. This single event not only gave us the moon, but it also helped stabilize Earth's axial tilt, contributing to the formation of a more temperate climate system and the rhythmic dance of tides. Though Earth was still a hellish, inhospitable place, these foundational steps were setting the stage for something truly miraculous: the emergence of oceans, continents, and ultimately, life itself. The fiery crucible of Earth's infancy was both a trial by destruction and a birth through chaos. It was in these explosive beginnings, in the chaos of stardust and collisions, that the seeds of habitability were sown. And the story was just beginning. In the sweltering furnace of early Earth, there was no sign of the vast oceans we now know. The planet's surface was a boiling wasteland of volcanic rock and toxic gases, and temperatures were so extreme that any water that existed could only remain in the form of vapor. Steam hissed through cracks in the crust, rising into a sky choked with carbon dioxide, methane, and sulfurous fumes. Earth was wrapped in a thick, alien atmosphere, more akin to the surface of Venus than our blue-green world today. But over millions of years, something began to change. Earth's violent infancy slowly gave way to a period of gradual cooling. The relentless impacts from space diminished, volcanic activity subsided slightly, and the planet started to lose heat into space. Around 3.8 billion years ago, the temperature finally dropped low enough for water vapor to condense. The atmosphere grew heavy with falling rain, an endless deluge that lasted for thousands of years. Torrents of water pounded the jagged rocks, carving out ancient basins and filling them with the first great reservoirs of liquid water. The steam-choked sky gave way to clouds and rainstorms, and the first oceans were born. These weren't oceans as we picture them today. They were acidic, dark, and filled with dissolved minerals from the newly formed crust. But they were vast, covering most of the planet's surface, transforming a once-scorched world into a shimmering, blue water world. This was a turning point not just in Earth's geology, but in its destiny. Water is more than a solvent, it's the medium in which chemistry comes alive. Within this vast planetary cauldron, something miraculous began to brew. Around 3.7 billion years ago, amid underwater hydrothermal vents and mineral-rich pools, the first signs of life emerged. These pioneering organisms were simple, single-celled, microscopic entities far from the complexity of plants or animals. Yet they were alive, capable of reproduction, growth, and metabolism. And with that, the spark of biology had ignited on a once-dead world. For hundreds of millions of years, these microorganisms quietly thrived in Earth's young oceans, multiplying, adapting, evolving. They formed slimy mats on seafloors, gathered around vents that spewed mineral-rich heat into the dark depths, and began transforming the planet in ways no one could have foreseen. Though invisible to the naked eye, these tiny life forms held within them the seeds of all future complexity. It would take nearly 1 billion more years before some of these organisms evolved new abilities, tools that would rewrite Earth's atmosphere, reshape its ecosystems, and pave the way for multicellular life. But even in their humble beginnings, these microscopic pioneers had already done the impossible. They had turned chaos into order, chemistry into life, and silence into the first whispers of biology. And so, from fire and steam came water, and from water came life, the first chapter of Earth's biological epic. Earth didn't remain a world submerged in endless oceans for very long, at least in geological terms. As the young planet continued to cool, tectonic forces began reshaping its surface from below. Deep within the mantle, massive convection currents slowly churned molten rock, pushing lighter, more buoyant materials upward. Over millions of years, these solidified portions of crust began to rise above sea level, forming the very first fragments of land. These ancient landmasses are known to geologists as cratons the stable, ancient cores of continents that have withstood the test of deep time. These primordial cratons were not continents as we know them today. They were isolated islands of rock scattered across the vast, global ocean, like stepping stones across a dark, planetary sea. But as more land surfaced and coalesced through tectonic movement and collisions, the Earth experienced a monumental transformation. The first recognizable supercontinent began to take shape. Scientists call this early continental formation Balbara. It wasn't a supercontinent in the modern sense. Its size was modest, perhaps smaller than present-day Australia. Yet for its time, Balbara was monumental. It represented the first major assembly of land on Earth, a prototype for the vast supercontinents that would follow. Composed of ancient cratonic shields, like the Kopval in South Africa and the Pilbara in Western Australia, Balbara gives us rare clues into the architecture of Earth's formative crust. This was a time before forests, before animals, even before multicellular life. The surface of Balbara was barren and brutal, scoured by harsh ultraviolet radiation, with no protective ozone layer in the sky. The terrain was rocky and volcanic, battered by meteorites and shaken by earthquakes. Yet beneath the surface, in the surrounding oceans, life was slowly adapting, waiting for its chance to leap onto the land. In this way, Earth's transformation from a vast ocean world to one with rising continents marked the beginning of a new geological and biological era. These first cratons and mini-continents would become the building blocks for the future supercontinents, the foundations upon which ecosystems, mountains, and eventually civilizations would rise. The stage was being set not just for life to continue, but for it to expand, diversify, and eventually walk the land. Roughly 2.4 billion years ago, a tiny but revolutionary life form rewrote the rules of Earth's survival: cyanobacteria. These simple, microscopic organisms evolved an extraordinary ability that would forever transform our planet: photosynthesis. For the first time in Earth's history, a living organism could harness sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. It may seem like a minor innovation, but it was anything but. Cyanobacteria were essentially Earth's first air purifiers, pumping out oxygen into an atmosphere that had never seen anything like it. Before their arrival, Earth's atmosphere was a suffocating mix of methane, carbon dioxide, and other greenhouse gases. It was toxic to the complex life forms we know today. But as cyanobacteria slowly spread across ancient shallow seas and sunlit tidal pools, they began enriching the planet with free oxygen, a waste product to them, but a miracle for life as we know it. This profound shift in atmospheric chemistry is known as the Great Oxidation Event. It didn't just add a breath of fresh air, it was a geological and biological turning point. Oxygen began reacting with other elements, triggering massive changes in Earth's crust and oceans. Iron in the seas oxidized, precipitating into iron-rich bands that still exist today as geological evidence of that transformation. But there was a downside to this planetary cleanup. With so much carbon dioxide being stripped from the air and replaced by oxygen, a far less effective greenhouse gas, the planet's natural insulation system weakened. Earth's temperature plummeted. The world, once warmed by a thick carbon-rich blanket, now faced a sudden deep freeze. The result was Earth's first major ice age, a dramatic global cooling event that cloaked vast portions of the planet in ice and snow. Some scientists believe glaciers may have reached all the way to the equator. This ancient deep freeze, often referred to as a snowball Earth scenario, turned our blue planet into a frozen marble drifting through space. And yet, life endured. Tucked away in warm hydrothermal vents, beneath the ice in liquid pockets of ocean, or in geothermal niches, life persisted, adapting to the cold, finding new survival strategies. It was a stark reminder that evolution is relentless, even under a blanket of ice. So while the rise of oxygen marked a moment of planetary progress, it also triggered a climate catastrophe. Still, without it, complex life could never have evolved. The same oxygen that nearly froze the planet would one day allow animals to breathe, fires to burn, and civilizations to flourish. This was not the end of the story, but the chilly, transformative beginning of a whole new chapter in Earth's living history. As Earth's atmosphere gradually transformed, its oxygen levels rising and carbon dioxide levels dropping, another monumental change was unfolding beneath our feet. The very crust of the planet was on the move. Tectonic plates, driven by intense forces deep within Earth's mantle, began shifting, colliding, and drifting apart. These slow but relentless movements caused land masses to merge and split, shaping the geography of our world over hundreds of millions of years. Eventually, around 1 billion years ago, these wandering continents came together to form what many scientists believe was Earth's first true supercontinent, Rodinia. Unlike earlier, smaller continental clusters, Rodinia spanned an enormous portion of the planet's surface, potentially making it the largest supercontinent in Earth's history. It was a colossal mass of rock surrounded by a vast ocean, with barren terrain and a climate that fluctuated between extremes. Meanwhile, deep in the oceans, life was undergoing a transformation of its own. Simple, single-celled organisms had already mastered photosynthesis and altered the planet's chemistry, but now evolution was about to shift into overdrive. Life forms became more complex, organized, and diverse. The biosphere was preparing for its next great leap forward. Eventually, Rodinia began to break apart, fragmenting into smaller continents once more. These pieces slowly drifted and came together again to form a new supercontinent known as Pannotia, which existed for a relatively brief moment in geological time. Although less well-known than its predecessor, Pannotia set the stage for one of the most astonishing events in the history of life on Earth. Between approximately 540 and 485 million years ago, life experienced a spectacular burst of innovation in what is now called the Cambrian Explosion. In an evolutionary blink of an eye, Earth saw an explosion of biodiversity as animals with hard exoskeletons, segmented bodies, and primitive nervous systems rapidly filled the oceans. These creatures left behind fossils, offering the first widespread glimpse into the alien seas of early complex life. The stars of this era were the trilobites, bizarre, armored invertebrates that looked like something out of a science fiction movie. They crawled along the seafloor in massive numbers, and their fossilized remains can still be found on every continent today. Other new creatures sprouted antennae, spines, or primitive eyes, radical experiments in form and function that laid the groundwork for the animal kingdom. But this flourishing era was not to last. Around 440 million years ago, Earth faced another dramatic upheaval. Climate patterns shifted, ocean temperatures dropped, and vast portions of the globe entered a deep freeze. Glaciers advanced, sea levels fell, and habitats vanished. The result was Earth's first known mass extinction event, the Ordovician-Silurian extinction. Nearly 85% of marine species were wiped out, including many of the Cambrian newcomers. It was a sobering reminder that evolution is not a steady climb, but a path of progress punctuated by catastrophe and renewal. Yet out of this chaos, life found a way to recover and even thrive. Between 420 and 350 million years ago, some of the most revolutionary changes in the biosphere took place. The first true trees pushed their roots into the soil and reached for the sky, transforming barren land into shaded, oxygen-rich forests. These towering plants stabilized the climate, enriched the soil, and provided the habitat needed for another incredible breakthrough: animals stepping onto land. Amphibians began to crawl from the swamps, trading fins for limbs and developing lungs to breathe air. In these humid forests and wetlands, the blueprint for vertebrate life on land was drawn. It was a new frontier, filled with opportunity and danger. And so began another chapter in Earth's long and astonishing story of survival and change. Roughly 250 million years ago, our planet was a very different place. Instead of a scattering of familiar continents, the land masses were all joined together in a colossal, unified expanse known as Pangaea, the last true supercontinent in Earth's long and ever-changing history. This sprawling landmass stretched from pole to pole, surrounded by a single vast ocean called Panthalassa. Imagine standing on its shores and seeing no end to the land, just one immense, rugged terrain that hosted a mix of mountains, deserts, and primitive forests. But while Pangaea was a geological marvel, its reign was tragically marked by one of the most devastating biological events our world has ever seen. During this same period, Earth suffered through what is now called the Great Dying, formerly known as the Permian-Triassic extinction event. This wasn't just a minor disruption in Earth's ecosystems, it was a full-blown planetary crisis. Triggered by intense volcanic activity in what is now Siberia, Vast quantities of carbon dioxide and methane were unleashed into the atmosphere, triggering runaway climate change. Global temperatures soared, oxygen levels in the oceans plummeted, and the chemistry of Earth's seas turned hostile to life. Entire marine habitats collapsed. Terrestrial ecosystems were decimated. In total, about 90% of all species plants, animals, fungi, and microbes were wiped out in this cataclysm, the most severe mass extinction event ever recorded. But from this near-total collapse, Earth began to heal. Slowly, the ashes of extinction gave way to new life. About 240 to 230 million years ago, in the wake of this desolation, the world witnessed the emergence of a new breed of creature, one that would come to dominate the land for over 150 million years. These were the dinosaurs. From small, swift carnivores to lumbering, long-necked giants, they evolved to fill the empty ecological niches left behind by the Great Dying. Their rise was both spectacular and inevitable, given the opportunities left in the wake of extinction. As this new Mesozoic era unfolded, dinosaurs rapidly diversified. You might have seen the towering Argentinosaurus, a sauropod so massive it likely weighed over 100 tons, making it the largest land animal that ever lived. If that didn't leave you in awe, then perhaps you would have turned and run from the thunderous steps of a Tyrannosaurus rex, whose immense jaw and razor-sharp teeth made it one of Earth's most terrifying apex predators. These creatures weren't just freaks of size and strength, they were masterpieces of evolutionary engineering, perfectly adapted to their environments. And while dinosaurs flourished, Pangea began to fracture. Over millions of years, tectonic forces beneath the surface cracked and pulled the supercontinent apart. Deep rifts opened. Oceans formed between drifting landmasses. Volcanoes erupted as plates collided or diverged. Slowly but surely, the single landmass gave way to familiar continents: Africa, Asia, the Americas, Antarctica, Europe, and Australia. This tectonic ballet would continue shaping Earth's face for millions of years, eventually forming the global map we recognize today. This continental breakup didn't just reshape geography, it reshuffled climate patterns, isolated species, and accelerated evolutionary diversification. With land masses drifting to new latitudes, climates changed, sea levels shifted, and entire ecosystems evolved independently. Some dinosaurs adapted to forests, others to arid plains or coastal wetlands. The world was becoming more diverse, dynamic, and dangerous. So yes, if you were standing on Earth during this tumultuous age, you would be living through a time of both destruction and renewal, of colossal beasts and continental drift, a world forever caught between chaos and creation. And while it may sound like the setup to a Hollywood blockbuster, this was no fiction, this was the real drama of deep time, written across the rocks beneath our feet. About 66 million years ago, our planet faced a catastrophe so immense, so sudden, that it reshaped the course of life on Earth forever. A colossal asteroid, roughly 10 to 15 kilometers wide, came hurtling through space and slammed into what is now the Yucatan Peninsula in modern-day Mexico. The impact released energy equivalent to billions of nuclear bombs detonating at once. Within milliseconds, an enormous crater over 180 kilometers wide, now known as the Chicxulub crater, was blasted into the Earth's crust, vaporizing everything at ground zero. But the asteroid's devastation didn't end there. The impact launched massive amounts of dust, soot, and sulfur-rich aerosols high into the atmosphere, forming a global shroud that blocked sunlight for months, possibly years. Photosynthesis ground to a halt. The global temperatures plunged in what scientists call an impact winter, throwing ecosystems into chaos. Massive wildfires raged, acid rain fell, and food chains collapsed from the bottom up. With plants dying off, herbivores starved, and so did the carnivores that hunted them. This chain reaction of ecological collapse was particularly brutal to the ruling giants of the time, the dinosaurs. After dominating the planet for over 150 million years, most of them, especially the large non-avian species, vanished. The event triggered the fifth major mass extinction in Earth's history, wiping out an estimated 75% of all life forms, both on land and in the oceans. It was the end of an era, a dramatic curtain fall on the age of reptiles. Yet, as in many moments of planetary catastrophe, this destruction also paved the way for renewal. In the eerie silence that followed the extinction, a new caste of survivors slowly began to rise. Chief among them were the mammals, once small, nocturnal, and largely overlooked creatures that had coexisted in the shadow of the dinosaurs. Now, they had a chance to spread, diversify, and explore niches that were once off-limits. With the great reptiles gone, mammals radiated into every available ecological space, some adapted to run, others to climb, burrow, or swim. Some became herbivores, others predators. They began to grow in size and complexity. These were the ancestors of the wide variety of mammals we see today: bats, whales, elephants, felines, canines, primates, and eventually humans. The age of mammals, also known as the Cenozoic era, had officially begun. And so, from the ashes of cosmic disaster, a new evolutionary chapter was written, one that would ultimately give rise to intelligence, culture, and the capability to look back across time and piece together this astonishing story of destruction and survival. Roughly 6 million years ago, a remarkable evolutionary branch began to form. The earliest known ancestors of humans began to roam the landscapes of Africa. Among them was a species called Sahelanthropus cadensis, a primitive hominid that walked this world long before recorded history. Though their posture was likely more quadrupedal than bipedal, they represented the first flickers of the path toward humanity. These early ancestors lived in a world filled with predators, fluctuating climates, and scarce resources. Their survival was hard-earned. By around 4 million years ago, evolution had nudged our lineage forward. New hominid species, such as Australopithecus afarensis, began to walk upright. This shift in locomotion bipedalism was a monumental step. It freed up the hands, allowing them to carry food, fashion rudimentary tools, and interact with the environment in increasingly complex ways. Walking upright also changed the shape of our spine and pelvis, laying the foundation for the human body we know today. About 3 million years ago, these early humans began developing the first known tools: simple but revolutionary instruments made of stone. They cracked open nuts, butchered animals, and began shaping their environment. These weren't just tools, they were extensions of the mind, reflecting an emerging ability to plan, learn, and pass down knowledge from generation to generation. With these developments, our ancestors started to diverge from other species more sharply. Then, around 800,000 years ago, a literal spark changed everything. Humans learned to harness fire. This ability to control and maintain fire was nothing short of miraculous. It allowed early humans to cook food, making it easier to digest and safer to eat, ward off predators, and survive colder climates. Campfires became gathering places. Around their glow, language likely began to take root, along with myths, songs, and the earliest forms of culture. The evolution of the human brain accelerated. Social bonds grew stronger, and communities began to form more lasting structures. As time passed, our family tree became crowded. There were Neanderthals in Europe, Denisovans in Asia, and other hominid cousins spread across continents. But between 40,000 and 15,000 years ago, all of these species disappeared. Whether through interbreeding, competition, disease, or climate change, one species remained: Homo sapiens. And they would go on to shape the world like no species ever had before. By around 10,000 years ago, human beings began to transition from hunter-gatherers to farmers. This shift, known as the Neolithic Revolution, marked the beginning of agriculture. Instead of roaming the land in search of food, humans began planting crops, domesticating animals, and building permanent settlements. This laid the groundwork for civilization. Towns became cities. Communities developed trade, governments, and writing. Religion, science, and art blossomed. From this moment forward, humanity began its rapid ascent. Fast forward to just 250 years ago, and the world changed again, this time at an unprecedented pace. The Industrial Revolution began in Britain and spread across the globe. Fueled by coal, steam, and human ambition, it sparked a transformation in every aspect of life. Machines replaced muscle. Cities expanded. People moved from farms to factories. Innovations like the steam engine, telegraph, and railroads redefined how humans worked, communicated, and traveled. The human population, which took hundreds of thousands of years to reach 1 billion by 1804, exploded in just a couple of centuries. By 1927, it had doubled to 2 billion. By the mid-20th century, it soared past 3 billion. And now, in the 21st century, we've reached over 8 billion people, each with dreams, stories, and needs, each consuming resources from the same fragile planet. But our unprecedented success has come with an equally unprecedented cost. We now face a new and looming threat: climate change. Driven by the burning of fossil fuels, deforestation, pollution, and industrialization, we've pushed Earth's natural systems to the brink. Global temperatures are rising, sea levels are creeping higher, and ice caps are melting. The oceans are acidifying, forests are vanishing, and species are disappearing at an alarming rate. We are now teetering on the edge of what could be the sixth mass extinction, a crisis not triggered by an asteroid or a volcanic eruption, but by our own actions. And yet, unlike the creatures of past extinctions, we have something they didn't: the ability to foresee the future and the power to change it. The question now is, will we act in time?